All right, so this is Physics Lab 1, which we looked at an object moving at a constant velocity. So introduction, so the purpose was to analyze the motion of an object traveling at a constant velocity. And the fundamental physics principles used was Newton's second law, which I'm sure you guys all know. But if you don't know, it's on the screen. F equals ma, that's the equation. And specifically to this lab, since we know that the velocity is constant, that means that the object isn't speeding up or slowing down, which means that the acceleration would be zero. And just by looking at the equation, if the acceleration is zero, then the net force on that object would also have to be zero. And what that means is that all the forces acting on that object or the system have to add up to zero to be zero. So that would mean that um, there would be forces acting on the object in different directions that cancel out or are equal in magnitude and opposite in direction. And the main model used in this experiment was the position time graph. And specifically with that graph, I guess the main thing from that graph that we looked at were the slopes, because we know that the slope of the position time graph is the velocity, or in other words, the derivative of position is velocity. Um, and then the system is the carts, and then the surroundings is the track and everything else in the cart's surrounding environment. And the reason why I say that is because in my experiment, I used one of the carts found in the lab, and I just rolled it on from one end to the other end of a track and recorded a video. Then I went into Tracker, tracked the point of mass, got the data and copied it and pasted it into an Excel spreadsheet. So for the code or the predicted position time graph, um, first I manipulated the starter code given, and as you see on the left, those are the initial conditions. I edited those. So for the ball position, I edited the initial condition to be zero, basically meaning that the ball starts at the origin or the cart in this case, whatever. And then the velocity is negatively sloped. The reason why I put the velocity to be negatively sloped or the velocity to be a negative value is because specifically in my video with my carts, the cart traveled from the right to the left, which if you think about the Cartesian plane, it would make sense that the velocity is negative because it would be traveling in the negative x direction, right? And this is just the predicted position time graph found um, on my the predicted position time graph found from GlowScript. Then I combined these two graphs and I put them on an Excel sheet. Um, and as you can see, the similarities are they both have a negative slope, meaning that they both have a negative velocity, meaning that they both traveled in the negative x direction. Um, and they both start at the origin, meaning they start at position x equals 0. And the difference is they both have different slopes or um, different magnitudes of velocities. And now to answer the two discussion questions. So for the first question, I said if I had the ability to change the orientation of the axes in the tracker, I would be able to change which direction the cart moved in, which would only change the sign of the velocity. In other words, this would change whether the slope of the observed position versus time graph would be positive or negative. In the next question, it's hard to tell exactly how many forces are added together in order to make the net force in this case. However, I do know that in order for the net force to add up to zero, all the forces acting on the system have to be equal in magnitude and opposite in direction. And then conclusion, when an object moves at a constant velocity, the slope of the position time graph is constant, meaning it has a constant slope, um, or a constant velocity. The acceleration of that object is zero, and the net force of that object is zero, as you can see from Newton's second law in the equation.